few weeks ago we blew up an IBM 5155, and in today's video we are going to repair it, do some more overclocking and some upgrades, and then finally we're going to try out some printed parts for this machine. Okay, so this is actually not a machine that we blew up twice, but I figured since we're working on 5155 stuff, we might as well work on this one too. Let's start with a quick test. Okay, unfortunately it is actually working now, but more often than not, this machine has messed up graphics. I'll see if I can find an older clip and insert here. We haven't blown up the drive in this machine yet, but with the rate stuff blows up on this channel, I wouldn't be surprised if it will before the video ends. Okay, so at the moment this machine clearly works, but let's get that graphics card out anyways. To get inside we need to remove 5 of the screws on the front panel. A regular Torx bit is a bit too short for the upper screws here, so I'm using my Mac cracker. With those screws out, we can pull the lid off. There's no need for a complete disassembly to get access to the cards, but we need to remove this shield here by removing a couple of screws. Okay, I think that's enough. So this machine came with a rather unusual graphics card. This video is sponsored by PCB for a very good reason, as you will see in a minute. Thank you PCB for supporting this channel. As far as I know, they were all delivered with regular IBM CGA cards. But this machine has been upgraded with a Hercules CGA card. This is the only Hercules CGA card I have ever seen, so I think these are pretty rare. Hercules usually have Hercules graphics, but not this one. Okay, so this card was actually working when I bought the machine years ago, but when I turned the machine on a second time after a few months, I got that glitchy screen. So I replaced these 2 caps and then tested the machine again, and it was working normally. But after a couple of reboots it stopped working again. So then I think I swapped these 2 VRAM chips. I'm not 100% sure, but I have installed 2 sockets and I have marked them with a green dot. So I think I have replaced them, or they are at least tested in another machine. And the card started to work again, but only briefly, and then I got that fault back again. So fixing a card with a glitchy chip like this one is really tricky. There's nothing I can measure or check. The only thing I can do is to swap components and then use it for a while to see if it starts misbehaving again. Okay, I went through my stash and apparently I have all of the logic chips in stock, but I'm not going to replace all of them in one go. Instead I'm going to replace a few of them and then use the machine for a while and see if it stops misbehaving. So I think some of these chips here are probably for the parallel port. So I think we can ignore these chips and start with the chips down here. This card, by the way, is a Hercules GB200. Now the strange thing with this card is that it has typical IBM numbers stamped on it. So that kind of implies that this was an IBM option. And I think I know why. Because the 5155 only had 2 full-length card slots. And all the remaining slots are for short cards like this one. So I think the customers who needed those 2 full-length slots for other cards, they could probably order the machine with one of these short cards instead of the full-length CGA card. But that is just my guess. While the desoldering gun heats up, I'm going to add some fresh leaded solder to the pins. And I'm going to install 4 of the chips in sockets for this test. And if we're lucky, this is enough for this card to stop misbehaving. And with the fresh leaded solder, this should be an easy job. This card looks like it would scratch easily, so I'm not going to wiggle. Yeah, this is just a 2-layer board. So that solder is coming out really quickly and easily. By the way, I haven't done any videos in 2 weeks. And that is because I've been traveling. But now I'm obviously back making videos again. Okay, all the legs are desoldered. So next I'm going to use the desoldering needle and gently check and make sure that every single leg is loose before I try to pull that chip off. And now, without using any force, I can just gently feel if the chip is actually loose or is still stuck to any of the pads. Yeah, and it wasn't. So this is a very safe method to remove chips. If you don't check all the pins with a desoldering needle first, one of the legs could be stuck to one of the pads, and if you pull too hard, the pad will be ripped off the board. Okay, the next chip was a bit more stubborn. All the legs are loose, but it's still stuck to something, and all that was needed was a tiny bit of heat from the rework station. There's still some solder left in some of the through holes, so I'm going to use some flux and then use some wick to get that remaining solder out. We better clean that mess up before we install the sockets. The solder mask was pretty crappy on this card actually, so it actually came off with the wick, and with the through holes cleaned up, the sockets now fit nicely. I like to solder just 2 of the pins, roughly in the middle, and then check and make sure that the socket sits flush before I solder the remaining pins, which they actually rarely do. So in most cases I reflow the solder and adjust the socket. Okay, all sockets are soldered, so we can clean up the flux. And now we can install some chips. So we've got one 74LS112, and then we have one 74LS00, and one LS374, and one LS244. Okay, more 4 chips replaced. Let's hope that's enough to fix this card, and the card can go back into the machine. As I mentioned, these 2 first slots are for full-length cards, and the 3rd slot here is long enough to take the original floppy controller, but not quite long enough to take a full-length card. And the remaining slots here are for short cards only. If you have watched the restoration video of this machine, you may have noticed that I have swapped the controller. So this machine came with an original IBM MFM controller in this slot here, but I have swapped it with the RLL controller from the Commodore PC-10, because that machine has plenty of space. So if needed, we could move these 2 cards to these short slots and install 2 full-length cards here. I'm gonna put the shield back on before we test this machine, because we have seen in a previous video what these drives like to do, and I don't want to have any burning tantalum in my face. Okay, here goes. Okay, so the display is working, but since it was, or perhaps still is, glitchy, the only thing I can do is to use it for a while, and hopefully the glitchy chip is now replaced. If it starts misbehaving again, I'll get back to this issue in a future video. Okay, so let's move on to the drive that we blew up a few weeks ago in the other 5155. So this damn thing blew up quite violently actually. It was quite a light show, and when I did an inspection I found 5 or 6 large burn marks. So first I thought I had blown up quite a few components in this drive, but when I did the edit I ran the video in slow motion. Kind of looked like there was a fireball flying from this end and just jumped around on the board and made it look like it was multiple components blowing up. So what I think happened here is that this tantalum here with a large gaping hole blew up and threw a burning tantalum ball that was bouncing around on the board here. And if we're lucky, this is actually our only fault. I'm obviously not just going to replace one tantalum. If this guy blew, these other tantalums are going to blow soon too. So let's replace the tantalum caps on this board, see if it starts working again. I have never repaired one of these before. I actually have a second drive that has stopped working. So we're gonna try to fix both. But first we need to figure out how to disassemble it. Aside from that regular screw, we also have a plastic screw that is also holding this transistor to a heatsink. And it's not coming off. And apparently it was because of a plastic nut. So that was an easy fix. And then we have a thermal pad that we need to remember to put back on. The polarity is marked on the board on some of the caps, but not all of them. So I made some marks just to make sure I don't install them backwards. Because if we do, they go bang immediately. So these guys are 4.7 micro 16 volts. And this guy here is a 1 micro 35 volts. And 4.716, 4.716, and the last one down here is 4.716. So if you're ordering parts for your project, you need 1, 2, 3, 4, 5 4.7 micro 16 volt caps, and 1 microfarad 35 volt cap. So let's add some fresh leaded solder before we remove these caps. And same thing here, this is just a 2-layer board, so this should be really easy to recap. And the other drive is actually a new old stock drive from Computer Reset. And it was actually working when I did a test, but when I decided to actually use it in a project, it wouldn't read disks anymore. So hopefully that's an easy fix. Well, I guess we're about to find out. Okay, all caps are off the board, and here's your beauty shot. This is the guy that caused all that fire and smoke. Unfortunately, I couldn't find any 1 microfarad 35 volt caps. I placed an order, and for now we're gonna have to try with this 2.2 micro 50 volt cap. Tantalums actually crack quite easily, so I like to bend the leads like this, because I have managed to break 2 of these. Maybe it's easier to see like this. So if I install the cap without bending the leads, it will sit flush to the board. And when you grab the card, it's quite easy to push on the cap accidentally. And then it will crack. So by bending the leads like this, it gets raised from the board. And instead of cracking, it will just get bent. Okay, all caps replaced and the board reinstalled in the machine. We might as well test the drive on the machine we already have on the bench. No need to take the other machine apart. Here goes. Well, nothing blew up. That's a good start. It's counting up the RAM. The drive spun up and it seeks. But the machine didn't boot. And I didn't get any errors on the screen. I'm just getting a flashing cursor. So we're not quite there yet. Well, it's a hell of a lot better than blowing up, but not quite good enough for me. So let's try with a cleaning disk. Reboot. It spins up. And then boots from the hard drive. Better add some more IPA and reboot a few times. Okay, let's try again with the boot disk. It reads, but it doesn't boot. So I'll try with a different floppy. Let's try with this copy. You never know when these go bad. It spins up, it reads, and then it stops. So unfortunately, this drive isn't fixed yet. Oh crap, it wasn't that easy. So unfortunately, that stupid tantalum killed something else on this board. That sucks. Okay, I just realized what might be the issue here. This machine is overclocked, and I don't remember by how much. And at a certain speed, the floppy drive stops working on these machines. So I'm going to remove the skinny sprint here and set it to original speed, because this machine doesn't have a turbo switch yet. So that is going to be the next thing we're gonna have to fix. Okay, said and done. Skinny sprint has been removed, and the original chip has been installed in the socket. Here goes. The drive spins up, it reads, and then it stops again. So it wasn't overclocking that was the issue either. Oh crap, we better test that floppy and make sure it's actually working. And unfortunately it works. So it's not the floppy, it is that drive. Okay, next I decided to recap the working drive that came with this machine. So this drive too now has a 2.2 micro 50 volt cap, instead of a 1 micro 35 volt cap. This should be a good test to see if that is causing our issue. And all these drives obviously needs a recap anyways. Okay, it's spun up and it reads. Okay, maybe we're onto something here. Better missing command com. Okay, the original 1 microfarad cap reinstalled in the working drive. Let's give this a try. It's kind of an unusual value. 1 microfarad 35 volts. I only keep 1 microfarad 16 volt caps in stock. Okay, it spins and it reads and it boots. Sometimes you can go slightly up in value, and I have done so successfully many times, but not always, as we have seen here. So these drives are a bit picky. Well, the next obvious thing to try is to reinstall the 1 microfarad cap in the broken drive. Okay, said and done. The blown up drive now has the original 1 microfarad cap installed. Here goes. Okay, it spins up and seeks. And it boots! Awesome! That's a win! So there you have it. The blown up drive now works. All that was needed was some fresh tantalum caps. And apparently these drives are a bit picky, so just make sure to order 1 microfarad 35 volt cap. And if you have one of these machines, you know what you need to do. These are, by the way, the same drives as in the PC Junior. And as I mentioned earlier, this is a new old stock drive from Computer Reset. It worked once, but then it stopped working. So I'm going to try the same trick here. I'll replace all the tantalums, but I will leave the 1 microfarad 35 volt cap and replace it later when they arrive in the mail. Okay, the new old stock PC Junior drive connected with all but one tantalum cap replaced. Let's see if this drive had the same issue. The drive spins and it seeks and it boots. Awesome. So same fault with this drive too, just some bad tantalum caps. Now this is really good news, because this drive is intended for a project that I've been trying to do for quite a while. And now that it's working, it's probably going to be the next week's video. I need to double check and make sure I have all the parts. Okay, the next thing we need to fix on this project is what I think is the most common fault with these machines. That is actually the flip-out feet here. They're pretty much always broken on these machines. And unfortunately they are of course not made anymore. But thanks to the sponsor of this video, I have a solution for this. Because someone made a printable project to make new flip-out feet for these machines. Since they break so easily, I went with ABS. And man, that is a really snug fit. These are really well made. Replacing these is super simple. We just need to disconnect the keyboard and then push on one tab on each side to remove the keyboard. Well, there isn't much left of this original foot, but enough so you can see how thin it is. And compared to this replacement here, this should hold up a lot better. So first we need to reuse the spring, then add this piece. Oh, I forgot to turn the camera on, but these are really easy to install. You just push them into position. This looks like it's going to work really well. And with the keyboard detached, and with the feet flipped out, you can keep the keyboard at an angle. It should be nicer to type on. Obviously connected to the machine. But the problem is, when you're done, and put the keyboard back on and fold it up, they probably all got broken off by people lifting the machine. So if you have one of these, don't forget to fold the flip out feet in. Personally, I never use them because I prefer to use the keyboard still connected to the machine. So there we have it. One more IBM saved by PCBWay. Thank you PCBWay for supporting this channel. Well, we're actually almost finished with this project, but there are a few more upgrades we can cram into this video. So first I'm going to install an AdLib clone, and it just about fits in here. I think there's about 1 millimeter of free space between the card and the floppy drive. And an XT without an AdLib card is kind of useless. So that one was obvious. The next upgrade I want to do to this machine is a turbo switch. This thing is obviously homemade. I just drilled a couple of holes in a blank and installed a switch and a push button. Then it connects to the skinny sprint. So you don't actually need a turbo switch to use the skinny sprint, if you plan to overclock up to 7 point something megahertz. But if you want to go faster, it's definitely necessary. So this skinny sprint had a 22.11 MHz crystal. Divided by 3, it was running at 7.36 MHz. But now I have swapped that crystal to a 24 MHz crystal. Divided by 3, it should run at 8 MHz. And at this speed, the floppy will get glitchy. Now this is a minor issue, because I'm obviously running this machine with a hard drive, and only use the floppy drive occasionally to install new software. And when I do, I can just flip that turbo switch, copy the software, and then put the machine back to full speed again, until the next time I need to use the floppy drive. But if you're running this machine with dual floppies and no hard drive, you're better off with a 22.11 MHz crystal. running at 7.37 MHz. Okay, skinny sprint and turbo switch installed. And if you're new to the skinny sprint, by the way, I've made a whole bunch of videos about this project. They should be easy to find on this channel. So with the turbo switch set to original speed, we can install check-it. And now we can run it from the hard drive. But first we need to switch to black and white. That's much better. It's hard to see on this tiny display, but we're now running at 4.77 MHz. So I'll flip that switch at the back. Now we're running at 7.99 MHz. And the machine is still running. So apparently this board is good for 8 MHz. That's awesome. That is a significant speed improvement from 4.77. Not too far from double the speed. We could try to go even faster, but then I need to source an 8284 chip that will go faster than 8 MHz. But unfortunately I haven't had much luck finding one of those chips on eBay. There is one seller, but he's selling fakes, so I'm not falling for that again. Okay, let's do a test and see if it's stable. Yeah, it totally is. This game runs really smooth on this machine at 8 MHz. So that overclocking is totally worth it. And this is actually the first time I tried this machine at 8 MHz. So I wasn't sure it would work, but it totally does. It's super smooth and apparently stable too. Well, unless you guys have any more ideas what we should do with this project, I'm gonna say this machine is complete. And that's all I had for you guys today, and I'll see you again next week.